Hey everyone, and welcome to today's Explainer. We're about to dive into something pretty amazing, uncovering the actual mechanics of how we learn to think, observe, and discover things exactly like real scientists do. So get ready to awaken your inner investigator, because the world around us is just packed with incredible puzzles, and they are literally waiting for you to solve them. Okay, let's dive right into this. Have you ever actually stopped to wonder, are there more grains of sand on all the beaches and deserts of the entire world? Or are there more stars in our galaxy? Or, on a completely different note, why exactly does a flat piece of dough, like a puri, suddenly puff up into a perfect little balloon the second it hits hot oil? I mean, these questions might sound simple, maybe even childlike, but they're incredibly profound, because science begins precisely with this exact kind of wonder. To really tackle these mysteries, it helps to think of a core metaphor: the roots and the kites. The root represents our deep, solid foundation of careful, real-world observation. It's what keeps us grounded in the facts. But the kites? Well, that soaring kite is our curiosity. You see, investigation in science only really works when we can balance that solid ground of careful observation with the absolute freedom of creative thinking. There's this absolutely brilliant guiding philosophy here. We don't want you to just learn new facts. We want you to learn how to find new facts. And honestly, that is so empowering. Our journey in this explainer isn't about memorizing some list of answers. It's about a massive transition. We're moving from just passively wondering why something happens to actively figuring out how we can discover the truth for ourselves. So how exactly do we find those new facts? It comes down to something called systematic investigation. Think of this as your ultimate investigator superpower. It means we don't just stare at something and guess. Instead, we ask highly focused questions, we design thoughtful, simple experiments, and we use our direct observations to clearly explain what we're seeing. That is how we improve our understanding of the world. Let's move along and see how this builds. Because this systematic approach literally scales across the extreme ends of our world. As investigators, our adventure spans from the microscopic all the way to the gigantic. On one hand, we can study single drops of water to uncover invisible microbial helpers that produce our medicines and learn how vaccines protect us from infections. But then we can zoom all the way out to study massive pressure differences in the air, the kind that can whip up a gentle breeze or unleash a completely massive, powerful cyclone. If we take a rapid tour through the physical sciences, you'll see pretty quickly that absolutely everything is connected. We're talking about how the magnetic effect of electric currents makes motors run, how invisible forces change the speed and direction of objects, and how understanding tiny, invisible particles moving around helps us classify pure elements versus mixtures. It literally explains everything, from the warmth in our homes to the wind blowing outside. And it's by understanding these invisible, fundamental forces, things like gravity or friction, that we can actually predict and make complete sense of everyday motions. It tells us exactly why a ball thrown up into the air simply must fall back down to the ground, or why a car safely comes to a stop the moment you hit the brakes. But science isn't just a bunch of high-level theories. It's incredibly practical, and it makes our everyday lives so much easier. Just think about the familiar appliances around you. We rely daily on the heating effect of electric current to power the room heaters that keep us cozy in the winter, or the irons we use to press our clothes. It's just a perfect example of fundamental science doing the hard work for us right in our own living rooms. Moving right along, our investigative journey also takes us into this super fascinating world of light. Figuring out how light bends through lenses explains exactly how corrective glasses help us see clearly. But it doesn't stop there. Watching how light reflects off the moon gives us the beautiful lunar phases. And by observing those periodic cycles up in the sky, early humans were able to create the very first calendars. Isn't it just amazing that the calendars organizing our daily routines today are linked to the motions of objects way beyond our planet? Now, what's really interesting here is that these observations aren't just limited to physics. They bring us right back down to Earth, straight into the complex web of ecosystems. Every single living being here is connected, from the tiniest insect and the frog resting on a lily pad, all the way to the fish in the water and the tall trees on the bank. They all depend on each other, responding to the air, water, and sunlight to form these marvelous relationships that support all of life. But here's the best part. To study all these amazing things, particles, forces, ecosystems, you don't actually need a fancy laboratory packed with complex equipment. Science is everywhere. Seriously, welcome to the kitchen laboratory. You can do real, systematic science right at home. Literally all you need is a hot pan, some dough, and your own curiosity. Let's treat a simple cooking session like a delicious detective story, all right? We'll just follow the scientific method. Step 1, ask a specific question, like what changes the way a curry puffs up? Step 2, figure out what things you can actually change, which we call our variables. And step 3, decide exactly what you're going to observe and measure to see if those changes actually made a difference. So the crucial point is knowing the clear difference between your inputs and your outputs. On one side, we have things we can control. Stuff like the thickness of our dough circle, whether we use Atta or Maida flour, or the exact temperature of that hot oil. On the other side, we have the things we observe, like counting the exact seconds it takes to puff up, noticing if one side ends up thinner than the other, or checking if the oil is splattering. Now, if you're going to do this experiment, you have to follow the absolute golden rule of systematic investigation. Change only one thing at a time. If you test different oil temperatures, you have to use dough of the exact same thickness and drop it in the exact same way. Keep thorough notes of everything you see and smell, and honestly, the absolute best part, a good experiment always leads to more questions. Does pricking a tiny hole in the dough change things? Does stored dough work differently than fresh dough? Okay, let's gently slow things down and zoom all the way back out from the frying pan to the scale of our entire globe, which is teeming with an incredible diversity of life. Earth is in this perfect, just right position. We're at the exact distance from the sun, where water remains liquid, and we're surrounded by this protective atmosphere that shields us from harmful rays while giving us the oxygen we breathe. It is a beautiful but very delicate balance. But as we know, this delicate balance is currently under threat. And that brings us to a deeply resonant truth. At the heart of both the problem and any possible solution is us. Human activities can cause small changes in the temperature of the Earth, which severely disrupts our climate patterns. We are totally central to this story. We're influencing the climate, yes, but we are also the ones who can guide our actions to fix it. So how do we do that? Well, it's by using the exact same skills we were just practicing in the kitchen. The tools of investigation, carefully observing, precisely measuring, and thoughtfully experimenting, those are the keys to protecting our planet. We can use these exact same scientific principles to solve these incredibly difficult, urgent climate challenges, with our curiosity acting as our guide. And please, never forget that there is always more to discover. Seriously, did you know that despite all of our advanced technology, scientists still don't completely understand exactly why a simple everyday porridge puffs up? It's true. The world is just full of unsolved mysteries waiting for your brilliant mind. So grab your notebook, keep your roots grounded, and let your kite soar. What will you investigate today?